Good morning, sir and ma'am. We are from group 114 TA 2021. We'd like to present our research about embeddings from language models representation, based bidirectional long short-term memory, and conditional random fields model for Indonesian name entity recognition. There are 7 things we would like to present. The first is background, the second is research question, third purpose, fourth scope, fifth research method, sixth analysis, and the last is design. Background. Name entity recognition is a form of natural language processing, a subfield of artificial intelligence that can be used to obtain name entities such as names of peoples, organizations, and places in a text document automatically. Name entity recognition is applied to the identification of entities in this article. Search algorithm to make them run more significantly, developing content recommendations for a medium, and handling customer support. In the case of name entity recognitions for Indonesia, there are still mistakes in recognizing several entities. This is due to the diversity of studies of meanings relations in linguistics, namely polysemy and homonym. In the study, Indonesian language text modeling will consider the problem of homonym and polysemy, and word sequence modeling will consider semantic information. Traditional word embedding will fail to distinguish between polysemy and homonym words. The word embedding cannot understand the context in which it is used. The word Elmo vector managed to solve this problem. The result from the word embedding will then be used to train the BiLSTM-CRF. BiLSTM knows about sentence context and CRF knows the logic in labeling. The advantage of the bidirectional long short-term memory method is that it can understand the context better. Next, CRF will provide next labeling. Sequence labeling is to provide a sequence of labels on consecutive objects. In sequence labeling, it is important to consider the correlations between adjacent labels. Therefore, in the study, the sequence labeling models adopt the BiLSTM-CRF at the top layer to predict the labels of all sentences simultaneously, and CRF takes into account the labels that appear previously, and each feature is weighted to calculate the next labels. Research question 1. How to model Indonesian text for name entity recognition case, and 2 is how to model Indonesian text by considering homonym and polysemy problems or semantic information. Research purpose 1 is to model the Indonesian text for the name entity recognition case, and 2 is to model the Indonesian text by considering the problems of homonym and polysemy or semantic information. Scope. The scope to be discussed in this research is that it can only accept input in the form of Indonesian in accordance with the guidelines for writing Indonesian spelling. Research method. There are 7 research methods. The first is problem statement. Second is study of literature. Third is analysis. Fourth is design. Fifth is implementation. Sixth is evaluation and discussion of results, and 7 is formulations of conclusion. Data source analysis. Dataset from GitHub repository public. BiLSTM repository can access from that URL. The dataset is labeled according to the standard NER format. For name entity classes are used, namely 1. Person, name entity of person entity. Second, place, name of place or location entity. Third, organization, name of organization entity, and the last is O or other name for other entity. This is the left side is the data set. Before it converts to 3 columns, and the right side is the dataset after it converts to 3 columns. So there are column token, kolom entitas bernama, and kolom kalimat. Number of entity, number of name entity. In dataset, a name entity was calculated for each token or word. For the calculation, the following results were obtained. So this is the graph of number of name entity with O other label. The left side and the right side show the number of entity without O other label. Token frequency. From the frequency calculation, the number of tokens is obtained based on their ranking in the dataset. The table shows the 20 tokens with the greatest frequency in the left side, and in the right side, it can be seen that the most frequent tokens appear is punctuation. Apart from punctuation, the most frequent tokens are dan, di, yang, LRB, RRB, dengan, pada, dari, tahun, sebagai, ini, untuk, dalam, adalah, menjadi, dan oleh.
Next is punctuation and URL frequency. The dataset is checked to see if there is a punctuation and URL. If there is a punctuation and URL, the calculation will be done for each punctuation and URL. For example, the punctuation. There are 57,483. The following table displays the sentence containing the URLs contained in the dataset. For example, beberapa lembaga pendidikan tersebut adalah pesantren Al-Furqan di Sigli Universitas Jabal Gafu. And in the next word is URL. Polysemy and homonym. The dataset is checked to see whether there are polysemy and homonym. From this table, we can see that there are word polysemy appear. For example, number 1. Sentence 1. He is the only child of the Tulus and Sahela couple. And sentence 2. The two large rivers of Kali Sarawu and their tributaries flow. The word child in sentence 1 show that the scandal of the pair Tulus and Sahela denotative meaning, while the child in the sentence 2 show another river in the branch of the Kali Sarawu River, or connotation meaning. And then here is homonym. The dataset preprocessing. In the processing stage, there are several steps such as case folding, text expansion, and bio-tagging. Case folding. The case folding stage is used in this study to change the input text into lowercase or lowercase letter. In table, it can be seen that the table still contains capital letter. The uppercase and lowercase letters of the first letter in a word can affect the calculation of the frequency at which the word occurs. This is done the homogeneous, the stored word cases in the simplicity, the word processing. This is also done in the order facilitate the embedding process and to measure the level of text similarity, because the words contained in the dataset are used as input for embedding. Number 2 is text expansion. Text expansion in the study is used to provide an abbreviation of the word that has been abbreviated. In the table, it can be seen that in the dataset there are still several non-standard words. Some non-standard words such as abbreviation, acronym, and other will be expanded so that the word is written included to the whole. The list of the expansion in the study you can see in the first appendix. For example, AN, atas nama, BPK, Bapak, DLL, dan lain-lain. Bioannotation. In general, in the NER text is seen the problem of predicting where the goal is to provide the correct label for each token. In encoding information, a set of labels makes a different representation of the place. The bio format divides name entities into beginning. For tokens, there are locating in the beginning inside for token after the first token if the name entities has more than one token, and outside for token that have not included defined for the name entities. Here is an example of using bioannotation can be seen in table below. For example, Alex B person, Anna B person, Medan B person, and Amplas I person. The other entities. Building model NER analysis. The first one is word embedding analysis. Text data before being processed by machine learning model and deep learning architecture must be first converted into numbers. The process of converting text data into numeric vector is called embedding. The result of the embedding will be used in machine learning modeling and serve as the basis of NLP computation. Some of the techniques that can be used to learn word embedding from text are word2vec, GLOVE, FastText, and Elmo. The second is BiLSTM-CRF analysis. In the study used BiLSTM-CRF algorithm in the labeling process. Each word in a sentence that has been represented as a vector is used as input for the BiLSTM-CRF model, and the output is a label that is predicted on a word in the sentence. BiLSTM will be used first to process each sentence or each token in the dataset. Next is evaluation analysis. Model performance is measured using confusion metric. The performance metric used are precision, recall, and F1 score during the training and testing process for each level. Evaluation is carried out to see how well the model is built in converting text into naming entities. The higher the evaluation metric value for word label, the average means the higher the performance of the model. There are 4 values in the conversion metric, namely true positive, true negative, false positive, and false negative. True positive means we predicted positive and it's true. True negative means we predicted negative and it's true. False positive, we predicted positive and it's false. False negative, we predicted negative and it's false. So here we can see the formula for precision, namely true positive divided by sum of true positive and false positive. And for recall, true positive divided by the sum of true positive and false negative. And then for F1 score, namely multiplication by precision and recall divided by sum of precision and recall multiplication by 2. Okay, my friend will explain the next presentation.
The whole scenario will be described as follows. An input dataset is a tokenized dataset called Singgalang dataset. In the study, we use 3 preprocessing steps, namely text expansion, scaffolding, and annotation bio. The output of these pre-processing steps is a pre-post sentence. Then, the dataset is separated into a train dataset to build a model and a test dataset to test performance. After a split dataset then becomes an input to process the word representation using Elmo embedding. At this stage, each word will be converted into a vector form so that it can be processed by the BiLSTM-CRF. The output of this text is a collection of tokens represented by Elmo embedding. Then, the token that has been represented by Elmo on the trained dataset will be used as input for modeling sequence labeling using BiLSTM-CRF. The output of this modeling is the collection of token pairs and labels that have been trained. After the modeling stage of the training is complete, the training result module data can be tested at the testing stage. When testing is done by taking tokens randomly obtained from datasets that were not used during the training stage, the testing data is tested with the models that have been obtained during the training stage. The output of the testing case is the result of the performance of the Elmo BiLSTM-CRF for name entity recognition. Text pre-processing design. The first one is dataset CSV will use as input to process text expansion. After that is scaffolding and view annotation. The data has been processed, produced the clean data that will be used in the filter extraction stage or called text representation. Its process at this stage will be described in the following section. First one is text expansion design. The input of this stage is dataset, and we have to make a list expand contraction and compare the word in a dataset with the word in expand contraction list. After that, we have the decision, are there any words that haven't been expanded yet? If no, it will terminate to finish, and if yes, it will change the word according the list and finish. Second one is scaffolding design. The input in this stage is dataset from text expansion. After that, we have to identification the uppercase in our dataset. We have to decision that are there a capital, and if no, we have to finish, and it will done. And if yes, it will change to lowercase. The third is view annotation design. The input in this stage is scaffolding dataset, and we have to make a set of conditional for checking text. After that, our system will check text for current and previous tokens. Our system will make one column for view annotation. After that, we have to make decision about does the token fit a set of conditional. If no, we have to check text for the current and present text again, and if yes, the result of this step is dataset with view annotation. After that, finish. Filter extraction design. The input of this state is data train and data test, and it will use to make a representation of word with Elmo. The output of this is pretend Elmo model and finish. NER modeling design. The input of this state is Elmo pretend model and used in BiLSTM layer. The output of BiLSTM layer is core vector representation and become the input of CRF layer. The output of CRF layer is the label text. After that, finish. the evaluation design. The input of the stage is take entity from the CRF layer, and we have to make count about F1 score, recall, and precision. And the output of the count that matrix value about the performance in this system and finish. The conclusion of these research are successful for making analysis data. The information obtained from there is used as a consideration for conducting a pre-processing text. In this study, 3 processing steps were carried out, namely text expansion, text folding, and bio annotation. The output of the pre-processing step is a pre-post sentence. Then the dataset is split into a trained dataset to build a model and a test data to test performance. The trained set and test set then become input to carry out the word representation process using Elmo embedding. At this stage, its word will be converted into a vector form. We have planning. In this study, we have to enter input in Elmo. Tokens that have been represented by Elmo on the trained dataset will be used as input for modeling sequence labeling using BiLSTM-CRF. Training result data will be tested by taking tokens randomly. The output from the testing phase is the result of the performance of the Elmo BiLSTM-CRF for name entity recognition. That's all I've been sharing. Thank you.